Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 85 is on the screen. That shouldn't take you long. I'll give you guys some time for that. Also, we are moving on, so you need to get a Cornell note ready. You do need a Freire model, so please do not lose a lot of time. Don't space out and focus. All right, I'll give you some time for that, and go. All right, here we go. Warm-up number 85. By now, you should be done. Let's see. Number 1. Approximately what? Anthony. E. 6.7. Hands if you got that. Looks about right. Number 2. Number 2. Let me graph it right here. There it is. There's f of x. All right. Our vertex is 0, 0. And then our new transform g of x is negative f x minus 3 squared plus 4. So, tell you here what's going to happen to this original function according to this. Then Anthony's going to pass someone. Pass someone, Anthony. Anthony D. Three to the right and up 4, so my new vertex would be at what? 3, 4, that's a new vertex. And what else? The negative 1 flips it upside down, so it's 3, 4, so somewhere up here and upside down. Hands if you got that. That is correct. Factor completely. Show your neighbor what you got for this one, and then we'll have Anthony D pass someone. All right, pass someone, Anthony. And x what? 3 times x plus 3 times x minus 5. Hands if you got that. That is correct. Let's go. Bailey from the corner. All right. 3b. Tell your neighbor your factors for 3b, and Bailey's going to pass it to someone. Bailey, pass someone. X plus 1 plus 3. Hands if you got that. That is correct. Let's go to number 4. Synthetic division. I'm going to go over this one just to make sure we got it. I'm giving you the extra practice. Here we go. Brandon knows? Okay. Brandon, Darty, help me out. What's the first thing we do? Standard form, yes. This is third degree. This is first degree. This is 0 degree. Is it in standard form? Yes. But is there a degree missing? Yes. Which one is that? 2, and you box it. Keep it in place because we're going to need that spot. Check this one. First degree, 0 degree. Yes, nothing missing. So then we write x minus 2 equal to 0, plus 2 plus 2, x equals 2, and that's going to be my divisor. There it is. So, since it is in order, I'm going to start with the number 7, which is the coefficient here. The second degree was missing. There's no second degree here, right? So what do I write, everyone? 0. That is correct. First degree is x. So what is the coefficient? -6. And then at the end, 9. bring down the 7. And let's start our multiplication. Here we go. What is 2 times 7? 14 goes there. Combine. That's still 14. Do it again. 2 times 14 is 28. Combine. That gives us 22. Again, let's multiply. 2 times 22, that gives us 44. Combine, and we have a remainder of 53. So, let's see. We started our polynomial with what? What was the original degree? 3rd degree, which means this becomes what? 7x to the 2nd power. That is correct. And then the rest is 14x plus 22. However, we have a remainder plus fraction 53 over, what is our divisor, everyone? X minus 2. All right? Last but not least, number 5. This graph, y equals -4 and x equals -2. Show your neighbor your graphs to make sure they have something similar to yours. All right, here we go. I'm going to graph y equals -4. That means I go to the y-axis, look for -4, which is down here, plot my point, and graph my straight line through that. Which means if I go to x equals -2, I go to the x-axis, go to -2, which is over here, plot your point, and a line going through -2. Hands if you got something like that. All right, send that in, please. All right, so how shall I say? Hold on to your horses, because today's going to be like a doozy. All right, copy the agenda, please. Warm up number 85, parabolas. We're moving on. Today we're going to derive a quadratic equation in your home place so that you do 4 of those sets. You're like, what do you mean, Mr. Q? Yeah, like you need to do exactly what we did here 4 times at home so you can go into your noodle. And I'm giving you extra practice because Friday's coming and this is new. All right, so please, pretty please, practice. All right, so please stop copying from people. Especially like with what we're going to do today. Once again, let me reiterate. Kind of like if I said like this. Let's say you're in track, and I'm all like, all right, I'll be right back. Can you go run 2 miles really quick? It's only 8 turns around the track, and I'll be right back. So I go to the gym, and I go talk to some other people setting up for the talent show because I'm going to be one of the judges, and I wanted to make sure all things are set up. And I go back, and I see you sitting over here on the side, and I'm like, it's only been 10 minutes since I've been gone. I'm like, I don't think they ran 2 miles in 10 minutes. So then I'm all like, excuse me, aren't you supposed to run the 2 miles? Yes, I already did. Really? You're not even sweating? Oh, I did it in my head. Wow! How is that going to help with muscle memory or mental muscle memory? It doesn't. Make sure you do your own practice, people. All right, y'all ready? Parabolas. You guys ready for parabolas? Oh, these are fun, man. I love these. Copy the code for your for the presentation. 3KNC9. 3KNC9. In case you missed something from the today's session, it's in there. And those of you that are following along on YouTube, once again, just getting some extra practice there. All right, here we go. I can derive a quadratic equation of a parabola. I can derive a quadratic equation of a parabola. The word derive is to produce or to create. We're going to create a quadratic equation of a parabola. Now the main concept here is in green, which is what? Parabola. So I want you to write that inside of your Frere model, parabola. All right, once again, I can derive a quadratic equation of a parabola. What is a parabola? Well, a parabola, here it goes. The set of all points equidistant, remind your neighbor what equidistant means. Equal distance, yes. But now instead of just one point like the circle, it's equidistant from a line known as directrix and a point known as a focus. Copy that? So, the set of all points equidistant from a line known as a directrix, notice that I did that in blue, and a point known as a focus, which is in red. So, writing utensils down, look up to the screen. I'm going to put some animation on this so you can see it. Y'all ready? So, a parabola. This is how it's formed. You start with a focus, and then that focus has to be away from the directrix. Look up. However, halfway in between the focus and directrix, if I place a point halfway right there, look up, focus, directrix, a point right there, and I start putting more points that are the same distance away from the focus and directrix, it makes something like this. Once again, the focus is the same distance from the directrix from here to here, from here to here, from here to here. So copy that, please. So, let me elaborate on this to make sure you understand how to form a parabola. A parabola, according to the definition, is made up of a bunch of points that are what? Equidistant from what? From a line and a focus. That means, according to the definition, that this distance and this distance is the same, because there's a point right there. Well, if I continue, that means this distance and this distance from the focus and the directrix, this point should be the same distance. And you can tell from far away, does it look like a little square? Look at it. Yeah, it's kind of like the same distance. That's why this is known as a parabola, and it forms using a infinite amount of points equidistant from the directrix, which is this line, and the point, which is the focus. Non-example, here it goes. Plot a point, label it C. Kind of crooked, sorry, let me try that again. A little bit better? Yeah. So, remind your neighbor how to form a circle. Tell them the key words. Keywords. Wow. A bunch of points that are equidistant from what? From the center. So why is this not a parabola? Because it's missing the what? Directrix. So, hashtag, what makes a parabola? Equidistant points. Hashtag directrix. Directrix and focus. So equidistant points from those two, directrix and focus. All right? Y'all ready? So, now that we know what they are, their equation looks like this. Look up to the screen. Don't copy it. Does that look familiar? Y equals ax squared. How about, look up. How about that? Does that look familiar? Yes. How about, does that look familiar? Kind of, sort of, yes. From here and there, we've been looking at some of these. But of course, you remember this one. Yes? That's what they look like in equation form. However, today's task, we need to come up with something that looks like this. So, turn your paper over. You're going to need an entire page. You're like, what? Oh, yeah. At the top, I want you to label it Deriving the Quadratic Equation of a Parabola. At the top of your paper, Deriving the Quadratic Equation of a Parabola. All right? So, let's see how we do. First of all, to make a parabola, tell your neighbor the two things that we need to sketch there on the paper really quick. What are the two things we need to sketch to get started? Yeah, the first one in red is the focus. So in red, make sure you have your colors. You will need them. I'm going to be using red, green, blue, and black. We need our focus. What else do we need, guys? A line, don't we? What is that known as? Directrix. That's going to be in blue. I'm going to label it Directrix. All right. So, here we go. To get started, we need a couple points here. So to get started with a parabola, we need a point right here between the focus and the directrix. I'm doing that one in black. Okay? All right. So, just so that we know where we're at on the coordinate plane, look up to the screen. Well, before that, here it goes. Look up. Question. Is this distance 1, the same as this distance 2? Tell your neighbor what you think about that. Is that the same distance? Yes. According to the definition, that's equidistant. Okay. So let me just move this just a tiny bit below. There it is. Okay. So now it looks pretty equal, yes? All right. So with that said, now that we established that distance 1 is the same as distance 2, we can start building our parabola. But let's see where we're at on our coordinate plane. Draw a black axis through there. That's going to be our y-axis. And draw another axis through the point, the midpoint between the focus and the directrix, going horizontal. And that is our what, everyone? X-axis. So far so good, yes? All right, stay focused because you need to come up with this on Friday by memory. All right? So let me zoom in just to make sure we see what we see. We started with a focus. We started in the directrix. And I said the distance from here to here is the same as the distance from here to here. So I'm going to plot a point right here on the directrix so that you can see that this distance is the same as that distance. Okay. Now, according to the coordinate plane, what can we label this point right here, everyone? 0, 0. That is correct. 0, 0. And for the sake of knowing where we're at, this point right here, check this out, I'm going to label this one 0 and P for the first point that I placed. Which the last point down here that I placed, if this one is 0P, what is this one? 0, negative P. That is correct. All right. Are we there so far? Okay. So, Mr. Q, but I don't see the parabola yet. No, because we need another point at least so we can see the curve. So check this out. Look up to the screen. So I'm going to take this point, look up to the screen, you're going to miss it. I'm going to take this point, and I'm going to imagine that I'm placing a bunch of points like that to make my little curve for the parabola. You guys see it? Picture it? So that means, can you picture it? Here it goes again. Imagine I get this point, and I start placing a bunch of little points, and it starts curving, and it starts making a parabola to the right side, yes? So now I'm about right here. So place a green point right there. So what are we saying, Mr. Q? Well, now that we have a new point, well, guess what? This is still, label it, this is still distance 1, because it's from the focus to that point. But according to the definition, this distance is the same as the distance from here to where? To the directrix, so place a point here. This is our distance 2. Give me a second. How are we doing? Good? So let's label these points. This one, we're just going to label it X, Y. Bless you. But this one, now that we have values, let's see. Look up. If this one is 0, negative P, and this one is X, Y, what can we label this one right here? Let's see. Share with your neighbor. What can we label that one? What can we label that one? What can we label that one, Kimberly? X, negative P. That is correct. X and negative P. That is correct. There it is. So far so good, yes? So what are we saying, Mr. Q? We're saying this, that now, look up, we can actually make a curve to start forming my parabola. Look how beautiful that looks. Q merch like a shirt, yeah? What do you guys think? $10 a pop? Woo-wee. All right. But that's only half, and you can imagine that I can do the same thing to the other side. But up to right there, from 1 to 5, how come far are you seeing the parabola starting to form? You guys see it? Yeah? Okay. I know it's a lot to take in. I'm just showing you where it comes from. So here goes the process one more time. I started with my focus. I drew my directrix. From there, I drew a midpoint between the focus and the directrix, and I said that this distance between the focus and that point is the same distance from that point to the directrix. That's why distance 1 is what? Equal to distance 2, right underneath. D1 is equal to D2. Distance 1 is equal to what? Distance 2. Now, does it work with any point? Well, let me see. If I place a point over here, which I did, and I label it XY, we said that this distance is the same as this distance. That's why D1 and D2 remain equal. How are we doing? Good? All right, good. You're like, I'm a little confused, Mr. Q, but I got your Nearpod code, and I have the video lesson that you're going to upload later today, and I'm going to follow it. Good. So, that's just half of it. We have to come up with an equation. Well, question. Didn't we say that this is a distance? This is a distance, is that correct? All right, remind your neighbor the distance formula that you guys did during a video lesson that you watched. Write it underneath here. D equals is square root, parentheses, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared equals to distance. So far so good, yes? All right. So, with that said, we're going to substitute values in here, so let's do another square root. Leave the x's blank, just put the minus in between. I'm not going to put the d anymore because I already showed you that that's the distance formula. All right, so we're going to fill in values in here. So check this out. I'm going to go to my sketch. Right now we are here. Look up, distance 1, right here. Look up to the screen. We're here. What was my first point? This one. So let's label this one in red, x sub 1, y sub 1. So that means if I'm looking at this distance, I have another point right here, which is the one in green. What can I label that one, guys? X sub 2, y sub 2. So you're like, oh snap, Mr. Q. Oh yeah, oh snap is right. So what is x sub 1 on this one, guys? 0. What is y sub 1? P. What is x sub 2 on this one? X. What is y sub 2? Y. Does everybody see that? All right, so let me scoot this up so I can do the substitution. Here it goes. I'm going to do x sub 1, y sub 1. So here underneath, x sub 1, y sub 1 is 0 and p. 0 and p. Do that, please. Focus. Pa. Which means for x sub 2, y sub 2, I'm going to substitute what? X and y. X and y. Okay, we good? Yes? All right. So, with that said, I'm going to continue right here. Y'all ready? Here it goes. So, the 0 is always going to be 0, so that leaves us with what? X squared. Plus, I still need to multiply this one out. Is that correct? So, y minus p times y minus p. So, let's see. Whoa, sorry. Okay, guys, if some of you make it big when you guys leave, remember, come back and hook me up some technology. My goodness. Here it goes. X squared plus, let's see, what is y times y? Y squared. What is y times negative p? Negative py. What is negative p times y? Negative py. What is negative p times negative p? Positive p squared. You're like, oh snap, Mr. Q. Oh yeah, here you go. X squared, y squared. What is negative py or negative py? Negative 2py plus p squared. Can we simplify any more? No, we're done up to right there. Okay? So, see where we're at? Let me zoom out really quick. We started here with our focus, directrix, and right now we are in distance 1 only. Distance 1. So let's go to distance 2. Again, distance. Get your formula going. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All right. So, what do we substitute over here for the distance 2? This is distance 2, right? I'm following distance 2 over here. So here we go. This one's already labeled x sub 2, so we leave it as that. However, I need this point. What is this point? X sub 1, y sub 1. You guys see it? All right. So x sub 1, y sub 1. So let's substitute those really quick. X sub 1, y sub 1, that is x and negative p. X sub 1, y sub 1. Okay. And what was x sub 2, y sub 2? X and y. All right, let's follow this along. Here we go. What is x minus x? 0. This cancels. So that leaves us with only this, which is what? What is negative times the negative? Positive squared. So we're going to write y plus p times y plus p. Distribute. Y times y squared, y times p, py, p times y, py, p times p squared. You're like, oh snap, Mr. Q, I feel like if I'm in pre-cal. I know, right? Let's go. Y squared. What is py plus py? Positive 2py. And then p squared. Can we simplify any more? Nope. That's it, right? All right, so let me take you to the beginning. Look up, guys. What did we say about forming a parabola? That distance 1 is what? Equal to distance 2. So look up, please. Let's finish this off. Put an equal sign here. This distance is the same as this distance. Focus, please. Here goes. So, to continue simplifying now an equation, because this is distance 1 equal to distance 2, how can I cancel this square root? Tell your neighbor. How do I cancel the square root? Yeah, squared. And whatever we do to one side, we do to the other side. So this cancels this, which leaves us with x squared plus y squared minus 2py plus p squared equals to y squared plus 2py plus p squared. Next, can we simplify more? Yes, Mr. Q, I can cancel out stuff. Look up, please, so you're going to miss it. Let's see. Do we have anything that's the same on one side than the other? Oh, sorry. Let me bring this back. Where's it at? Okay. Right here. We're almost done. What's the same here and here? Y squared. What else can we cross out? P squared. You're saying, why did you cross it out, Mr. Q? Well, look up. If I was to get rid of p squared here, I subtract p squared, and I do the same over here, they're going to cancel. So what does that leave us with? X squared minus 2py equals to 2py. And in order to solve for x squared and leaving x squared by itself, because we need a quadratic equation, what do I need to do here? Everyone. Add 2py. Add 2py. Whoop, sorry. Add. So that leaves us with x squared equals 4py. Box that one. This is our equation that we're going to use for our parabola. Woo-wee. So you're saying, so what is the home plate, Mr. Q? Let me zoom out. That. You need to do 4 of those. 4. Let me show you how. You start with the graph first. Then you write D1 equals D2. You write your D1 formula, substitute values for that first distance. Then D2, set them equal to each other, simplify, come up with this equation. Do one copying from your notes. The second one you do it again. Try to do it by memory as much as you can, and then go look at your notes. The third one that you do it again. Hopefully you're completely almost done without looking at your notes. And the fourth one you do from memory. If you need more, then do more. You know, like athletes, that if you need more practice, you put more practice in. So, oh, and by the way, look what this forms. Check this out. You're going to be like, aw, snap. Aww. Look at that. Let's go. We love it. You only need at least 4 of these, please, for home play. And I'll stop the video right there. I'll upload this right after lunch. So if you need to reference the video by yourself, there you go. Or make it a family math night or something, you know, get everybody in it. Gather around. Let me show you the deriving a quadratic equation for a parabola. Yanni? No? All right.